Hi, in this session we'll be talking about object relational mapping, and we will try to understand it with the help of a Java application called Bookstore. In that application, we will create an object graph of a book object and persist it into a relational database called Bookstore. And after that, we retrieve the same object graph of that book object back from the Bookstore database. And we will do that by writing JDBC and SQL code. And while doing that, we will see if there are any problems in that approach and how the object relational mapping could help you solve those problems. So here are the three classes we'll be having in our application: the book class, publisher class, and the chapter class. And the diagram here shows the associations between them. A book has a publisher and it can have one or more chapters in it. And here are the three tables we'll be having in a Bookstore database: the book table, publisher table, and the chapter table. And the relationship between these tables is shown in the diagram here, where the tables are associated with each other with the help of their foreign keys. So here are the classes that we have in our application. And all the classes have the getter and setter methods for their data attributes, and also a toString method to print a meaningful output for their objects. And here is the database schema for the Bookstore database and the three tables in it. We are using MySQL as the relational database management system here, in which we have the Bookstore database. It's okay if you do not know SQL or how to write database schema. Just assume that you have a database developer in your development team and he has written this code for you. And here are the tables that will be created in the Bookstore database. The only interesting thing that you might find here is that in the chapter table, both the chapter number and the ISBN of the book are used to define its primary key. And that's because it's only the combination of these two will make a chapter unique. So we need both the chapter number and the ISBN of the book together to uniquely define a chapter. So we have a Bookstore service class that will be used by a Java client called Bookstore client to persist and retrieve the object graph of the book object. And the Bookstore service class will do that using JDBC, which is used to connect a Java application to a relational database. And it will require the JDBC driver of MySQL for that, which is just a jar file that we need to have in the class path of our Bookstore application. So let's first have a look at the Bookstore client class and see how the object graph of the book object is being created. We first create a publisher object and then the book object, and then we associate the publisher object with the book object. And then we create a collection of two chapters and associate it with the book object as well. And after all that, we use the Bookstore service object to persist the whole object graph of the book object into our Bookstore database. And the end result is going to look like this. We'll be having data of the book object and all the objects associated with it inserted into the tables of Bookstore database. Now let's move on to the interesting part of writing Bookstore service class. Now, too many things are going on here, and it's okay if you've never worked with JDBC or SQL before. You will never have to write this code if your application uses object relational mapping. But it's only good that we cover this, as it will help you understand the object relational mapping better. So let's go through it step by step. So we are loading the JDBC driver first and making a connection to our Bookstore database. We are going to require this connection to execute any SQL statements against the database. Next, we prepare the SQL statement here to insert the data of the publisher object into the publisher table. And the way we do it is by copying the values of the data attributes of the publisher object into the parameters in the prepared SQL statement. So the code of the publisher goes to the first parameter and the name of the publisher goes to the second parameter. And then we execute the prepared SQL statement by calling the execute update method, and after that we release the JDBC resources acquired by prepared statement object right after its use by calling its close method. Next, we follow the same procedure to insert the data of the book object into the book table. And similarly, we insert all the chapters of the book object into the chapter table. And we've got all this code wrapped inside a try-catch block to handle any exceptions thrown while executing the code here. And then finally, we close the connection object, releasing all the database and JDBC resources acquired by it. So now you've seen how to persist a simple object graph of a book object here using JDBC. But there are some problems with this approach. To start with, we are writing all the SQL code here ourselves. And if we are Java developers, we might not want to learn a new language to process the data of our Java objects into a database. And even if we have the understanding of SQL, we might not find writing SQL code very pleasing. The second problem is that when we are using JDBC, we are writing too many SQL statements for a simple task of persisting the object graph of the book object in our application. Imagine the case when we are working on a fairly complex application and the object graph of the book object in that application is way too bigger than the one we have in our application. The third problem is that there are too many copy codes being written here. When we are persisting an object, we need to copy the data attributes of that object into the parameters in the prepared statement object. And the fourth problem is that the SQL code that we have written here is dependent on the relational database management system we are using. The SQL code we have written here is for MySQL, and it might not work with any other relational database management system. So in future, if you plan to change your relational database management system, then you might have to come back and change all the SQL statements that we have written here. So these are the problems we'll be facing when we are working on a Java application and using JDBC with SQL to persist a graph of objects into a relational database. Now let's move on to retrieving the object graph of the book object by its ISBN value. So again, let's have a look at the bookstore client class first that will be calling the retrieve object graph method on the bookstore service object to retrieve the book object with its object graph using its ISBN value. And this is what the result would look like using the toString method we saw earlier in each of the Java classes in our application. Now let's move on to the bookstore service class again and this time have a look at the retrieve object graph method. So again, quite a bit is going on here and we will go through it step by step. First, we load the JDBC driver and make a connection to the bookstore database. Next, because we have to create an object graph of the book object, we will have to read data from multiple tables. So this time we are preparing an SQL query statement that will read data from both the book table and the publisher table. And this SQL query is going to filter the results based on the two conditions in it. The first one says that it should retrieve only the data where the value of the publisher underscore code column in the book table matches with the value of the code column in the publisher table. And the second one says that it should retrieve data only for the ISBN value that we pass into the first parameter of the SQL query statement. Next, we pass the value of the ISBN of the book object into the prepared query statement to read data from the book and the publisher table. And then we execute the prepared SQL statement against the bookstore database, which gives us a result set that contains the data returned from the database from which we create the book and the publisher objects by copying the fields of the result set to the data attributes of the book and publisher object. And then we are manually associating the book objects with the publisher objects. Then we close the first result sets and prepared statement objects and release any JDBC resources acquired by them. And then similarly, we are querying for all the chapters that a book has in it with the given ISBN value. And then we are using its result set to create a collection of all the chapters by copying the fields in the result set to the data attributes of the chapter objects. And then again, we are manually associating the collection of chapters with the book object. So again, we are writing the SQL code, and again, we are working with the low-level JDBC API. And again, we've got too many copy codes here when we are copying the fields of the result set into the data attributes of an object. And again, the SQL code here is database dependent. But another problem we are facing here when we are retrieving the object graph of the book object by its ISBN value is that we are manually handling the associations between all the objects associated with the book object for creating its object graph. And this is just a simple application. Just imagine the work you'll have to do as a Java developer in a fairly complex application if you're writing all the JDBC and SQL code yourself. So all these problems we faced in a bookstore application were because of the mismatch between the object model and the relational model, and all of them could be solved by object relational mapping. Object relational mapping is a technique of mapping the representation of data from Java objects to relational database. And it allows you to use Java objects as representation of a relational database. And it does it by mapping between the plain old Java objects that you write in your application and the relational database. And this mapping is done either by XML or annotations. So it helps you take advantage of the features present in object model and the relational model and hides the complexity of directly dealing with the SQL and the low-level JDBC API. It writes all the JDBC and SQL code for you, and it could even create the database schema for your application. So here are the plain old Java objects that you have in your application, and with object relational mapping in place, you'll be able to map them and their data attributes to the tables and their columns to store data for them. And once you've done the mapping between your Java objects and your database, you'll be able to persist this object graph of this book object into this relational database just by calling a simple Java method and passing the reference of this book object into that method. And again, if you want to retrieve the object graph of this book object back in your application, you could do that by calling another Java method and passing the book's identifier into that method. So, being a Java developer, you do not need to write any SQL and JDBC code in your application. And if you're working on a fairly complex application that requires persistence, it will save you enormous amount of development work and improve your productivity.